Can anyone confirm if audio, video, etc. everything looks fine before we get started? Hello, hello. Hey, hi, short side. Can anyone confirm if audio, video, etc. everything looks good before we jump on to the solution discussion? I think I will skip code forces today. I think I have two lead code contests to discuss for, and I think that will simply take away all the time. So that's where we are. Hey, hi, this. So yeah, like can anyone confirm if audio video looks fine, and then we will start jump out to the solutions for this problem. Hello, hello. I think let's give a couple of minutes. All good. Okay, thank you. This. So yeah, I think mostly this is a Telegram channel where you can find the announcements, and I'm right now discussing this, with, and later on I will upload this as a video on the channel. I think this is your view. So I think the agenda for today's discussion is like the biweekly contest that happened yesterday and the weekly contest that happened today morning. And I will do it this way: like first problem of one contest, then first problem, second, third, fourth. In your absolute difference between two values, it says you are given integer nums consists of 0, 1, and 2. A pair of integers for valid if num I is 1 and num j is 2. Return the minimum absolute difference between I and j among all the valid pair. If no valid pair exists, return minus 1. Absolute difference is defined. So we have to mostly implement what have been asked to us. Like we will have two for loop, one for I, one for j, and then we will simply return whatever we get. Not sure how does this works. Like, is there a way I can pull my submission? into editor. Okay, yeah. So we start answer as like let's say 2n because we know that absolute distance difference can never be 2n because the length is n. One for loop for I, one for loop for j. If ai is 1 and j is 2, then mark answer equal to I minus a. And if answer is greater than equal to 1, return minus a equals to return 0. And I think this is the solution for the first problem of the biweekly. Any questions, anyone? If not, let's jump onto the first problem of weekly contest. It says you are given string s of length and consists of lowercase letters. Return a smallest index I such that si equal to s n minus I minus 1 if no index is returned. Again, we have to implement what simply asking the solution. One for loop for I and check if si is equal to the given condition, and that's where we. N is length of s, for I is range, and if si equal to si n minus 1, then return I, otherwise return minus 1 if you don't find it. Any questions, anyone so far on the first two problems before jump on to the next problem? Okay, yeah. So it says we are given three integers n, pos, and k. There are n people standing in a line numbered from 0 to n minus 1. Each person independently chooses a direction. L visible only to people on the right, R visible only to people on the left. For this person, if the character is L, then the people on the right side can see him. If the character is L, then people on the left side of his left side can see him. A person at pause sees others as photos. If I less than pause, it's visible only if they choose L. If I greater than pause, it's visible only if they choose L. Return the number of possible directional assignments such that the person at index pause sees exactly k people, and now we have to print in more 10 in 9%. So essentially, the way problem looks is as follows. So we have a person pause. Like we have multiple folks here. We have multiple people here, and each of them has some characters assigned to them. Let's say left, right. This is the guy we are focused on. Then let's say we are focused on this guy. Then this guy can see this person, but it he cannot see. They cannot see this person. And this guy can see this person. They cannot see this. They can see this, so they can see this. This is the case. Wait, what? 1 second. Only browser is visible. or they can see this person. Essentially, the idea is we have different people. Now we have left and right characters for each of them, and we can see a person can see all the people with the character right on his left side and all the characters L with are on his right side. Now we need to know. Now we are given the position of people, a particular person in this list of people, and we are given n total number of people. And now we need to find number of ways. So that exactly k people are eligible to this person. So, like this is our problem statement. That's why we have A people on left. Like, let's say we choose A people on left side, which would be equal to cos B number of people on right, A number of people on left, and one like the person itself. And if we say that I people have L on the right side, the number of ways to find such people is A, C, I. And then we don't have a choice. Now we need K minus I people on the right side. Now we need this sum for all I between 0 to. Since we don't really care about what's the left or right of the current person, we multiply it by 2. So this would be our answer, where is like the permutation and combination. NCR is n factorial upon r factorial and minus r. So this would be our solution, but it can take quite a long, and then you have to print in mod 10 plus 7. All those things like our constraints are way too high. Up to 10 running a for loop like this will simply take away a lot of time. So there is one more way to look at this problem. Let's say we divide each character into favorable and unfavorable outcome. When person at pause can see favorable outcome for I, favorable direction for I person. For person I. And similarly, we have unfavorable. And the way we define it is, if I is less than pos, then like the favorable direction would be if their character is I. And I greater than pos, or if I less than pos, then unfavorable position would be I. And if I greater than pos, then favorable position is I. And I greater than pos, then favorable position is I. So now earlier I was counting the number of people with character L on left side, number of people with character R on right side, and doing some calculations and all. Rather, I have changed the way we are looking at this problem. We say that a favorable direction for person I with respect to person who is at pos is if on left side it's the character R, and if on right side it's the character R. Left side L, right side R. And unfavorable is the opposite, left side R, right side L. Then if I look at this expression again, it's essentially counting the number of favorable people we have on left side, which is I up to A, and then number of ways to count number of people with favorable direction on left side, and number of people with favorable remaining number of people on with favorable direction right side. Or can I say like all I need in this problem is favorable direction. Number of favorable direction is equal to K, because like that would be the number of people that would be visible to this guy, right? And among n minus 1 people, number of people with favorable direction K would be n minus 1 Ck, and multiplied by 2, because we don't really care about the what's the direction of the person who is at position. And this would be our answer. I think how do we calculate NCR etc. with mod n minus, and that is something that part I will skip. And you can probably look at like a lot of available resources on the internet. They have this like it appears quite frequently. It would be great if you can take a look at it. But yeah, like for the sake of this analysis, I will skip that part. Like I think NCR is the crux of this problem, but I will probably skip it for now. And the answer is NCR n minus 1K into 2 with the given number. So yeah, I think I was kind of using LRU cache instead of an array. NCR, like the definition of factorial is this. Like this is how you find the inverse factorial of a given factorial. And then NCR is factorial n minus inverse factorial of R comma n minus R. That's where we are. So this was problem B. Any questions, anyone, before we jump on to the next one? Given that I would be back in a minute. Any questions, anyone, on this problem before we jump on to the next one? So I think in that case, I will jump on to the next problem. It should be second problem of the Leetcode weekly contest. Design event manager. So it says you are given an initial list of events where each event has a unique event ID and a priority. Implement event manager class where event manager I comma this event initializes the manager with the given events where event I is event I comma priority. Void update priority where we need to update the priority of the event of the active event with this ID and new priority. And poll highest removes and returns the event ID of active element with the highest priority. If multiple active events have same priority, it returns the smallest index among them. If there are no active events, it returns the minus one. And event is called active if it has not been removed by this method. So essentially, again, we have to implement three functions. Like we are given a list of events, each with an ID, comma priority. We have an update method that gives us an ID and new priority. And we have a method which says poll highest. and it gives the method that has highest priority. And if there are multiple, then it picks the smallest index, and then it also removes it from the list of the events we have. And I think I don't really remember all the methods in Python, so I ended up coding it in C++. So what we essentially need is two things. One, a method event priority map, of which is, or I think it would be better if I simply code it, because this problem is more on the coding side. Weekly contest. This is 490. So we have a map. We will maintain a map which says event priorities. P equal to, it maintains id equal to p. And whenever an update comes up, and the new priority, like this can keep all the priorities up to date for each of the elements. Now we also need the map. The way I am doing is like you can either maintain a priority queue and then you have to sometimes look at whether the data is stale or not. Or the way I did it was using a set, and the idea is like what we want is descending order based on priority, and then if there are types, then in increasing order of id. First, like basically, and the ties should be broken in the ascending order of the IDs. So this is how we will end up putting it here. Like we have an old priority here. We need to remove it from queue and insert the new one. Insert new priority, remove old priority. Like you can use priority queue, but priority queue does not allows us to have an erase method, so I ended up using it. Now if our priority queue is empty, we need to return -1, or we can pick the highest IDX, which would be the index of last element in this priority queue. And essentially, since we are adding negative index to break the ties, we add minus negative here. We also remove the event from the priority queue, and then we return this index. So this would be the solution for the second problem. Any questions, anyone? Any questions, anyone, before we jump on to the next problem? So yeah, like let's move on to the next problem. Minimum XOR path in a grid. It says we are given a 2D grid of size m, n. We start at the top left cell and we want to give to the bottom right cell, which is m-1, n-1. At each step, we will either go right or we will go down. And the cost of the path is defined as bitwise OR of all the values in the cell on the path, including the starting and the ending cell. We need to find the minimum possible XOR value among all the valid paths from 0, 0 to n minus 1, m minus 1. And yeah, like the constraints are like the length can be up to 1000, the breadth can be up to 1000, the number of n comma n, like the total number of elements would be less than 1000, and each of the value would be less than 1023. And now like we have to find, and essentially the solution is the dynamic programming. So like the way folks are solved is as follows. Like mostly it's dynamic programming, and dynamic programming will work because you can see like the number of a dynamic programming is like, let's just maintain a visited array. It says if we start from 0, 0, we follow some route. There can be many different ways for that route. Like another way to reach here would be this. Nice. I am just drawing out some of the possibilities. And among this path, is there any path which leads to the current XOR as XR? This is R comma C. And if we can compute this for every single cell, then we can simply check the values of n minus 1, m minus 1, and XR. And whatever that minimum value is true here, we will simply return that value. And like this is how we should be doing it. And the way the transitions would happen is, if we are at R comma C with value XR, either we can go one cell right down, and our new XOR value would be XR, and the new cell which we are at. Or we go one column right, one column, and like the new XOR value would be And like this is how all of our transitions will look like. This is the size. Total possible XOR values here. Now we run a DFS. You start with 0, comma 0, comma 0, and your current XOR is 0, comma 0. And you also pass along the DQ value here. Like possibly pass on the same DP value. If we have already visited this R, C, and XR, then there is not really a need to go any further. Otherwise, DP, R, C, XR becomes true. If we have a column left, then run it for R plus 1. Okay, we need to also pass on A here. And we actually need N command as well. So we are here. and then we go through all the possible jaws at the last index. The very first DP value we can find here, we will return it. And yeah, I think this would be the solution here. Oh, that looks like some check is there. Look, we know that this is the false alarm. Like one value must be true here, but nevertheless, so this would be the solution for this problem. Any questions, anyone? Yeah, like how to become good at iterative DP? I am currently able to find memorized solution, but struggling in iterative one. I think the solution will again be like try to solve problems that are on iterative DP. You can probably look at USACO guide to find problems related to iterative DP. So like the idea is the moment you solve a lot of iterative DP problem, then only you would be able to solve it. And the idea is whenever you come across a DP problem with a recursive solution, then try to find out how to do it in iterative form. Like there are a lot of solutions on Leetcode solutions tab only, where people give a lot of different ways to solve a problem. So for every problem, DP problem you come across, you try to see whether it can be solved using iterative DP or not. Yeah, I think that would be the way to solve over here. Like you can try to solve it. Like there is no good DP problem. Like the moment you keep solving the problem, you will keep figuring it out. And the problems rarely repeat. The ideas do repeat. I think, frankly, I don't have a list of DP problems right now. Otherwise, I would have shared it. But that's where we are. So this is where we are. Any questions? Anyone on this problem? Before we jump onto the third problem of Leetcode weekly contest. So yeah, I think probably at this point of time, ChatGPT and all are good. You can probably try to search there what are the most common simple DP problems are there, and it will give you some lead code links that you can try out. Okay, like I think the remaining problem, all of them are hard. I think yes, three hard problems. It says I think laptop is lagging a bit. It says we are given an integer array nums of length n. An integer k is called sortable if k divides n, and we can sort nums in non-decreasing order by sequentially performing following operation. Partition nums into consecutive subarrays of length k. Cyclically rotate each subarray independently any number of times to left or right. Return an integer denoting all possible sortable integers k. A subarray is a continuous subarray sequence of elements within an array. So it says we have an integer array of a of length n. Now for all the divisors that are of length k, all the divisors of n, divide the array into blocks of k length, and then you can cyclically shift each of those blocks. And once you are done with that shifting, check if you can make all the arrays sorted or not. We cannot move subarrays around. We can only shift each of the subarrays by some value. So and like we have to find out some of all the devices that can make arrays sortable. So again, I think the solution would mostly be coding what we have. So we have an array of length n. If k does not divide n, we simply skip it. Otherwise, we check if sorted. Can the block of k make it sorted? If answer is yes, we add this to the answer. Now we run into a for loop of all the length blocks. Now first we have to shift this current array L up to R, and let's say we get the array we receive is C. Now let's find the smallest index over here. And then now we shift everything with respect to the minimum index. We first add everything from min index, or I think we can just keep it like this. Like this is our cyclic rotation. If C is not sorted, like does anyone knows? Okay, I don't know if there is a method if sorted or not, but the way we can do is like we can first check if C is sorted or not. This is where we are, and we keep like what is the maximum number we have found so far. We can start with as some negative numbers. If the current number maximum we have found so far is more than the smallest number in C, we return false. Otherwise, we update current max equal to C, like the last element in the maximum. I think this looks tempting. There is a bug over here, but I think let's first submit it in the current form. Okay, yeah, we have a WA, and the test case like 1 to 1 fails here. For example, in the array like 1 to 1, the minimum index we are taking is this one, and if we try to wrap it around like then this will remain same. Or look at the array like this. Like the correct sorted way over here would be 1 1 1 1 2 3. So what is the solution here? We need to ignore the element which are equal to the starting element in the given array. And I think that's the only remaining case over here. Before doing any shift, then we'll just skip the starting elements. and this will ensure that everything else remains fine. I think it will fail still again at one place. Like we need to keep at least one element equal. Like basically, essentially, it means all the elements are equal. That what? So this is problem C. Any questions, anyone? Before we jump onto the next problem, like the last two from one problem from each of the contest. Any questions, anyone? It says we are given an integer array digit sum of length n. An array ARR of length and is considered valid if every value is between 0 to 5,000. It's non-decreasing. Every value keeps like like there is like 1 1 2 2 3 3 4 4 5 5 and so on. Sum of digits of ARRI is equal to digit I. And we have to count the number of distinct valid arrays, and answer can be very large, so we have to print in mod 1 in 9 plus 7. An array is said to be non-decreasing if each element is greater than or equal to the previous element if it exists. And this is where we are. So yeah, I think overall the idea here is this. We say DP as number of ways to fill numbers from A0 up to AI, such that AI is equal to X, and all the conditions are already satisfied, like basically digit sum of AJ is equal to DJ for all the index j less than equal to I. Then let's say how do we find DPA? If digit sum of X is not equal to DR, then we cannot fill X at this position, so the number of ways is 0. And if it's equal to DR, then the number of ways is sum of DPI and all the numbers 0 up to X. Like we don't need a for loop again here. Like we can either maintain prefix sum or something, or we can maintain a running previous sum to find it out. And I think this would be the overall idea for this problem. Numbers are up to 5,000, right? Digit sum of the numbers before it plus the last character. Let's call it D. We need everything as mod as well. Range M. If D sum digit sum of X is not equal to DI, continue. If this is the first element, BPI equal to 1. And we maintain like basically the running count of all the elements. Or I can, the way I will put it is if it's the first index, we keep it like this. Like previous sum would be the number of elements. Essentially, like we are maintaining this sum when we are at 3, we maintain the I minus, like this should be I minus 1. I minus 1, 0, 1, 2. When we go to x equal to 3, we also add I minus 1, 3. When we go to 5, we also add I minus 5 and so on. This should be DPI. At last, we return sum of DP and minus 1 percentage. Any questions, anyone on this problem? So this was the last problem of biweekly contest. Any questions, anyone on this problem? We have one more problem remaining, which would be the last problem of this weekly contest, and then we will wrap up for today. Any questions, anyone? This is again a hard problem. Incremental edge with cycle queries. It says you are given an integer n, and there is an undirected graph n nodes labeled from 0 to n minus 1. Initially, the graph has no edges. You are also given 2D array of edges from UI, Vi up to Wi. Represent an edge between UI, Vi with weight Wi. The weight Wi is either 0 or 1. Process the edges in the given order. For each edge added to the graph, only if after adding the sum of weights of edges in every cycle in the resulting graph is even. Return an integer denoting number of edges that are successfully added to the graph. So it says we are given a graph, every edge weight is either 0 or 1. Now we keep on adding the edges to the graph, but if at any point in time when we add an edge, there becomes a cycle of length odd, then we have to skip that adding that edge. And this is where we are. So like the problem is hard because I think it requires knowing DSU, crystals, spanning tree algorithms and everything. So it again also says like we need to maintain DSU algorithms, return set union. Like my idea would be like this. Let's first add such that no cycles are created. Let's first add edges such that no cycles are created. Basically, create spanning tree. No cycles are created. This would be one. Like this would be the first thing we would do over here. And then for each connected component that basically each pair of connected nodes we get, like for example we have this node. Let's also add hatch weights here. Then in each of the connected component like this, we will try to put in numbers related to one of the parity compared to one of the node here. So if we start from here 0, the parity or odd or even would be 1 here. It would again be 0. It would be 1. It would be 1. It would be 0. If we start from here 0, 1, 0, zero, 0. Like this can be done by doing one DFS over here. Now let's say if we try to add the node here. Then since these two parities are same 1 and 1, if we add a 0 degree 0 weight edge, then this cycle would have even parity and we are good. But at the same time, if we try to add weight 1, then we cannot do it, because now you will have a cycle of length 1, 1, 2, 3. So this would be the idea. For the nodes with same parity, we can only add 0 degree node. Or for the nodes where for example this is 0, this is 1. Then here we can add node with parity 1, so that like all the values satisfy. But here we cannot add 0 and 1, because if you add a 0 here, the cycle would be 1, 0, 2, 3, and it will make the condition wrong. So overall this would be the idea. First we will add all the nodes such that no cycles are created. Then for each of the nodes we will assign it 0, 1 based on relative parity of one of the node in that component. And then we will try to add cycles there and see like what happens with each of the cycles. Like if both the ends of the cycle have same parity, then you can only add 0 there. Or if both the ends have different parity, then you can only add 1 there. And that would be the overall idea for this problem. For this you need to know like DSU, disjoint set union, which I am skipping for the sake of this discussion. You can find it on USACO guide about the disjoint set union. Mhm. And you can also find some practice problems here. Like practice implementation, how what disjoint set union is, and practice problems, everything's there. Actually, I do follow chess. Like I used to follow a lot during COVID times. Um, I know right now candidates is going on. Like it starts today, I believe. So like I do have this Y combinator here, but I think you can assume it to be some fancy way to do recursion and nothing over there. Wait one second. You can check it out here. Like Or you can just assume that this is some fancy way to do recursion, and that's all. So this is one black box I have for this solution. And then I have a DSU implementation, which is also a black box for us. And with these two black boxes, I will try to solve this problem. So I will create a graph with all the edges that would be. I am first trying to add edges that does not create a cycle. So I have a DSU, and I also keep the edges that I am yet to add it. And the count of edges we have. I go through all the given edges of the graph, U, V, and W. If adding U and V will create a graph, will create a cycle, then I will skip this for now. We can simply put it back again. Otherwise, we add U and V into the same component, and we create a graph edges between U and V with the required given parity, and we also increment our counter by one. Then I will maintain the parity for each node. What is the parity where I'm trying to do a DFS? What is the current parity? If parity is not -1, then we have already assigned some parity over here. Otherwise, we assign parity of U as current parity. Then I do a DFS again here. From the first node of the parent, and the parity of node changes by whatever the edge parity was, and that's where we are. And now I go over all the edges that I initially did not add it for. Path parity will simply be the parity to reach U from one node. And if we add W as way to it, if it becomes odd, we skip it. Otherwise, we add it to our answer. And this would be our overall solution for this problem. Any questions, anyone? And I think with this, I'm mostly done with the problem here. So I think this wraps up the problem discussion stream for today. Any questions, anyone? I think I would try to have one more stream like the same time every week. Let's see how long I can do it. Thanks everyone who has been here so far, and do follow, do check out the Telegram where I would post announcements. And yeah, I think I would stream it on Twitch, and then VOD would be available on my YouTube channel. So I think this is where we are. Thanks everyone for joining today. I think I have couple of more minutes. If you have any questions, do send them across. I can try to answer them before we wrap up for the today's stream. Any questions, anyone? So all right then. Thanks everyone for joining in today. Thanks a lot.